This is moles and Stoich, review number 2. If you want to find percent water in a hydrate using the formula, the question might say something like, find the percent of water in copper 2 sulfate pentahydrate. We would have to know that the 2 means that copper has a +2 charge. We can look up sulfate on table E, which has a -2 charge. When we crisscross and drop the signs, like charges with opposite signs will cancel, and the formula becomes CuSO4 with a dot, and then 5H2O, penta meaning 5. In order to find the percent of water, we're going to want to find the gram formula mass, which we do the same way that we do for any other substance, except for the fact that we're going to keep the mass of water all together and multiply out by the coefficient for the water in the formula. So we will get H2O times 5 equals 90. When we add it all up, the total for the gram formula mass will be 249.6 grams equals 1 mole. To get the percent of water, we will take the total mass of the water, which is 90, and put it over the total mass of the compound, which is 249.6, and multiply by 100. Our percent of water comes out to 36.1%. If we want to find the percent of water in a hydrate using data, the question might say something like the mass of a hydrate was 8.7 grams before heating and 5.6 grams after heating. Find the percent of water in the hydrate. The wet salt has a mass of 8.7 grams before. That might also be called the hydrated salt. We're going to subtract the mass after heating, which is the mass of the dry salt, which also might be called the anhydrous salt. And when we subtract, we'll get the total mass of water lost. In order to find the percent of water, we're going to put the water lost over the hydrate mass, which is the original mass before heating, multiplied by 100. And in this case, the percent of water, according to this data, comes out to 36%. If we want to find the percent of water in a hydrate using a different kind of data, they might give us more involved data, where they might give us the mass of an empty crucible with its cover. Remember, the crucible is the container. Give us the mass of the crucible, cover, and the hydrate crystals before heating, and they might give us one or more masses, including the crucible and the cover, after the heating. We're going to need to find the percent of water in the hydrate. In order to do this, the first thing we're going to do is subtract the mass of the crucible from the mass before heating with the crucible and the crystals, and the lightest mass after heating with the crucible and the crystals. Subtracting the mass before heating minus the crucible mass will give us the mass of the hydrate crystal alone before heating. Subtracting the mass of the crucible, cover, and crystals, that is the lightest after heating, minus the mass of the crucible, will give us the mass of the dry anhydrous salt, which is the mass after heating. And if we subtract the wet salt minus the dry salt, we will get the total mass of the water. Again, we're going to put the mass of the water over the mass of the hydrated crystals before heating times 100, and we will get the percent of water in the hydrate, which in this case was 36%.